Nyquist sampling theorem. For real signals, half the sampling rate is known as the Nyquist frequency limit. This is the highest frequency that can be represented by the particular sampling rate complex quadratic signal equation. Twice the bandwidth for a given sample rate for baseband complex signals, the frequency range is negative Hertz 0 plus Hertz, where Hertz is half the sample rate. For non-baseband signals, the frequency range is twice the real signal. The Nyquist theorem, also known sampling theorem, is a principle that engineers follow in the digitization of analog signals for analog to digital conversion to result in a faithful reproduction of the signal. Slices called samples of the analog waveform must be taken frequently. The number of samples per second is called the sampling rate or sampling frequency. Any analog signal consists of components at various frequencies. The simplest case is the sine wave, in which all the signal energy is concentrated at one frequency. In practice, analog signals usually have complex waveforms with components at many frequencies. The highest frequency component in an analog signal determines the bandwidth of that signal. The higher the frequency, in practice, analog signals the greater the bandwidth if all the factors are held constant. Suppose the highest frequency component in Hertz for a given analog is frequency max. According to the Nyquist theorem, the sampling rate must be at least 2 frequency max or twice the highest analog frequency component. The sampling in an analog to digital converter is actuated by a pulse generator clock. If the sampling rate is less than 2 frequency max, some of the highest frequency components in the analog input signal will be correctly represented in the digitized output. When such a digital signal is converted back to analog form by digital to analog converter, false frequency components appear that were not in original analog signal. This undesirable condition is a form of distortion called aliasing. These are the frequency sampling. Every point here is the signal form. For every second point, now you can see the signal form. Here is the third and the fourth, then the sampling signal. As you can see the graph, every color of the signal must be here. That's all, and thank you for watching.